Hi, welcome back to the Calculus 1 lecture series. And in this video, we are continuing working on the Chapter 4 practice test. And it's for the unit application of the differentiations. And this is our video number 3 here. We did previous two videos we covered part 1 and part 2, and now the video number 3 we're going to cover the part 3 of our practice test. So now let's continue. Let's go to our practice test. Okay, so here we're going to find the limit. So this is a computation part. So part 3 is here. Okay, so let's go ahead and start. So in here we said you can use any methods you learn through the all the lectures here. Okay, so here this is a sine x approach to infinity. So this number going to approach to infinities, right? And when the x approach to infinity, pi over x, what is going to approach to? Going to approach to 0. If a pi over x approach to 0, so what is the whole signs here going to approach to? Approach to zeros here, right? So we have infinity times 0. And we know the infinity times 0 is indeterminate form. So we will try to use the L'Hopital's rule, but the first one I need to change. Remember the L'Hopital's rule is 0 over 0 over infinities, right? Okay, so now let's try to change that. Okay, so the first things here, I will leave the sign pi x on the top. Then I will flip this 1 over x. Right? So now I have the form, I change this to the 0 over what? Over 0. And then I can use the L'Hopital's rule. So here we said the L'Hopital's rule will allow us, so this is limit x approach to infinity, and 1 over x is x to the negative 1, right? So you take the derivative, will be negative 1 x to the minus 2, so it will be 1 over x squared. And the sine we know is going to be what? Cosine pi x. And then don't forget the chain rules, right? Chain rule will be pi over 1 over x. So you take the derivative of pi over x will give you negative pi over x squared here. Okay, now let's try to simplify a little bit. So that is the negative x over 2, negative x over 2 going to cancel. So I'm going to have limit cosine pi over x. So I know the pi over x is going to approach to what? Approach to zeros, right? So then I know what is the cosine 0 going to approach to? We're going to approach to 1. So now let's what here. So now my answers here, this is going to approach to 1. And then we still have a pi left here. So it's 1 times pi. So this is pi here. Okay. Now let's take a look at the second one. Limit x approach to infinities and x minus natural log x. In fact, we know, remember we talked about the rate when we approach to infinity, which one is faster. So we know the exponential is the fastest one, and x, and then the natural log x is behind x. So by just from that concept, I know x minus natural log x, even both of them approach to infinities here. So this is infinity minus infinities, right? So we know the infinity minus infinity is indeterminate, but the x is go a lot faster than the natural log x. So I know this answer going to be infinity, but I cannot just tell you, say, hey, x is go a lot faster, right? So we need to find a way to formally show it. Okay, so now let's see, how can I do it? Well, we have infinity minus infinity. There's no square roots of something. I cannot do the conjugate. So what I can do, maybe I can factor the x out. So if you factor the x out, this will be what? This will be the natural log x times x over x, right? Okay, now let's put this one out. So when the limit approach to, let's take a look at this one separately. Limit of x approach to infinity, This is natural log x. So what is this one? This one going to give you what? The infinity over what? Infinity. Then we say, oh, this is L'Hopital's rule. So then I can say by the L'Hopital's rule, I can say this is limit x approach to infinity. I take the derivative. This is 1 over x. This is 1. So this will be the limit x approach to infinity, 1 over x. Now, what is this one going to? This one going to equal to 0, right? Now, I can have here, so this one going to approach to 0. So this will be limit x approach to infinity, the x times 1. Now, what is x approach to? X approach to infinity. So this is the infinities here. Okay, now let's take a look at problem number 3 here. Problem number 3, let's take a look at what is this going to approach to. When x approach to infinity, the e to the negative x, e to the negative x is 1 over ex. So when x approach to infinity, this will approach to 0. So this whole thing will approach to infinity to the 0 power. And as we know, this is what? This is not a determinate form, right? So this is indeterminate form. But now with the exponential, what do we need to do? We need to set the natural log. So we let the y equal to, this is x to the e the negative x, right? Now we say, let's take the natural log y. So if you take the natural log, this will be the e to the negative x, natural log x, right? And then now you can put this one, this is natural log x, e to the what? E to the x. Now you let the x approach to infinity again. So what happens here? This approach to infinity, this approach to infinity. But now they approach to the infinity, I can use the L'Hopital's rules. Right? So I can say the limit x approach to infinity, the natural log x ex will be equal to the limit x approach to infinity. You take the derivative separately. Natural log is 1 over x, ex still will be itself. So what happened here? So this is limit x approach to infinity. So this is 1 over x ex. Right? So both of this one approach to infinity. So what is the whole thing approach to? The whole thing approach to what? Approach to zeros, right? And then don't forget, because this is a natural log y approach to 0, and we want to the y. So what do we need to do? We need to y it back, right? So we know the y will just be e to the 0 power. So what is here is 1 here. So that's why I know this limit here will approach to 1 here. Okay, now let's take a look at this one here. Okay, so for this one here, number 4, so when x approach to 0, this will be the square root of the 1 minus the square root of the 1. So top is what? Top is 0. And the x approach to 0, what is this one? Bottom is 0. So it's 0 over what? 0 over zeros, right? So then you say, okay, I can use what? I can use the L'Hopital's rule because it's 0 over 0. Or this one, it will work if you use what we learn in the limits unit. You can just take the conjugate. So let's try to take the L'Hopital's rule, see what happens here. So the derivative of the bottom is 1. So the 1 plus 2x, the square roots, right? Let's say this is 1 plus 2x to the 1/2, right? So we take the derivative. So this will be 1/2. And then this is 1 plus 2x to the negative 1/2. Don't forget what here? Chain rules, right? So it's times 2. Okay, then you minus, right? So that here the same, 1 minus 4x is equal to what? It's 1 minus 4x to the 1/2. So this is 1/2. then this is 1 minus 4x to the negative 1/2. Then don't forget what? Chain rules, right? So it's negative 4. Okay, now you let the limiter. Okay, so I need to, let me see here, I put the arrows here. So I said now the limiter x approach to 0, right? So from here to here, this is L'Hopital's rule. Now let's see here. So what is the limit approach to 0? X equal to 0. So this term equal to what? This term equal to 0. This term equal to what? Zeros, right? Okay, so now let's simplify it. So 2 and 2 is what? Is 1. So this is 1 times the square root of what? Square root of the 1. Then this is a negative, negative is a positive, it's a plus 2. Now what is here? 1 over square root of the 1. So the answer here is 3 here. Okay. All right. Now let's take a look at number 5 here. The number 5, I have x over x minus 1, then the natural log x plus x minus 1 here. Okay, so first let's take a look at natural log x, right? This will be what? Be the negative infinity. So I know the whole, then this one is 0 minus 1, the whole denominator will be the negative infinity. And then now let's take a look at what is this x over x here. Okay, so we did this before in our like a homework helper. So let's try to take a look here. So this is y, because this is the x over x, 0 over 0 power, right? So 0 over 0 is indeterminate. So let's set y. Okay, so let's take a look at natural log y is equal to x natural log x, right? Okay, so x times the natural log x. So now when the limit x approach to 0, so when the x approach to 0, this one is approach to 0, this one is approach to the negative infinity. So what do we need to do? We need to, flip it, right? So this is limit x approach to 0. So we have a natural log x, we have 1 over x. And then we say this is the limit x approach to 0. So what is the natural log x? The derivative is 1 over x. And what is this one? Is negative 1 over x to the square, correct? Then you flip it. So this will be limit x approach to 0. So the negative x is going to x will become 0. And don't forget, this is a natural log y. So in order to get y, what do we need to do? We need to e back, right? So we need to use the e to back it. So what is the limit here? This one is 1. So this is 1 minus 1 will be equal to what? 0, right? Okay, so now in here, okay, so take a look here. This is the zeros, right? So the top is 0. Bottom, when the bottom going to the negative infinity, so what is the whole thing will be 0, correct? So this one, the whole thing is really was kind of equivalent, so we're kind of equal to like a negative infinity of 0. And this is determinant forms, right? Because the 0 is on top, and then you have a denominator becomes bigger and bigger, the whole thing is getting smaller. So this is a determinant form. So the limits for this problem is equal to what? Equal to 0 here. Okay. Now let's take a look at the number 6 here. This is x e to the x over 2. Okay, so let's take a look. Let's try to get rid of this. So this is square root of x. This is e the x over 2, right? So because negative exponents. Let's take a look at what is this one. X approach to infinity. So this is approach to infinity. X approach to infinity. This approach to infinity, right? So because exponents is extremely large, so I have infinity over infinity. Okay, so if I have infinity over infinity, then what rule I can do? I say, oh yeah, I can use the L'Hopital's rule. So I will say the limit x approach to infinity, I take the derivative. So this will be 1/2 x to the negative 1/2. Then this will just be the e the x over 2, then chain rule times 1/2. Right, so this 1/2 and this 1/2 we can cancel. And then this one we're going to become to limit x approach to infinity. And then this is the square root of the x, and this is ex over 2. And so what happened here? This will be infinity. This will be infinity. So it's 1 over infinity. So what is here? This is 0, right? So the limits for here is 0s here. Right? So those are the very, kind of the important limits problem. So you can use sometimes you can use the limits method we learn in the limits units, or you can use L'Hopital's rules, right? But remember, right, the L'Hopital's rule is you need to have a 0 over 0 or infinity over infinity. If it's not, then you need to try to find a way to change it to this one. All right, so the next one's here, the graphing. So here, let's take a look. Those are very good concept type of problems here. The graph here, be careful. This is f primes, right? Okay, so this is f prime here. So we said the interval f increase. Okay, so in here you can do like here you can try to find so this is a 0, 1, 2, 3, 4, 5, 6, right? This is f prime, all right? So f prime, from let's take a look here. This one's to tell you, so it's less than 1 is what? It's negative, right? It's negative here. And from the 1 to 5, it's all positive, right? Then from the 5 to 6 become negative again because this is f prime. And then I know if I want to find the increase, if f prime, that means the f function. So this will be decreasing, increasing, 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 and decreasing, right? Okay, so this is once here, we said increasing on where? The increasing start once, right? So from the 1 to where? 1 to 5. And the decreasing is from where? From the 0 to 1 and 5 to 6 here. Okay, and now we want to find which interval f is a concave up. So we know the concavity is depend on what? The concavity is depend on the f double prime, right? Okay, so now let's take a look. How do we do this one? See here, right? So you graph it. Okay, so you need to have a kind of a very clear idea here. So you graph it, right? Right. So this is 0, 1, 2, 3, 4, 5, 6. All right. So you want to find what is the f double prime here, right? So you want to know is f double prime is increasing or decreasing. Okay. So we know the f double prime is the derivative of what? F prime here. Correct? So this is a derivative of f prime. Now the f primes here, let's take a look. F prime is increasing, right? Increasing from 0 over 3. So that means from increasing, 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 right? So this is f prime. And then after 3, the f prime become decreasing. So it's decreasing, 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 right? So I know. Okay, so f double prime is the derivative of f prime. So if f prime is increasing, so what is f double prime here going to be? The f double prime going to be, so the f double prime going to be positive, 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 right? Then this is negative, negative, negative. All right, correct? So it's a positive, positive, negative, negative. Okay, now I can start to, so I will say, okay, now I can convert to the F's, right? Okay, so be careful, this 3, right? So this is positive, positive. So this is concave up, concave up, concave up. Then this is a concave down, and the concave down. See here. So I know it's a concave up, is from where to where? 0 to 3, and the concave down is from where? 3 to what? 3 to 6. That's right. Okay, so now I want to look for the local max. Local max is dependent on the f primes, right? So this is increasing, increasing, increasing. So where could be the local max here? Okay, so the local max here, right? So this will be the local max, and right, because this is increasing and decreasing, right? So okay, so this is f prime. Sorry. This is f prime. So f prime, the local. Okay, sorry here. Okay, so I don't have so. Okay, so this is not okay. All right, so now I know here, let's be careful here. And so the f prime equal to 0, right? So this is f prime equal to 0. Let's see here, f prime equal to 0 at 1. So this point, right? So this point and at this point equal to 0. Okay, so this is f prime. Okay, so so now let me get a different color, maybe purple. Okay, so now in here, the f prime, right? So f prime from negative to positive. So that means my function is what? Is decreasing, right? Then positive, so it's increasing, increasing, and increasing, increasing. And then for the phi is decreasing. Okay, so now where is the, so in here you say this is decreasing, right? So it's negative. Let me double check negative. So f is decreasing, increasing, 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 decreasing. All right, so where is my local means here? This is my local means, right? The local max is at x equal to 5. Local mean is 1, that's right? And then the inflection points here, the inflection point is the concavity. So concavity change here. All right, so the concavity change here, right? Because the concave up change to concave down. So what is my concavities here? So the inflection point will be x equal to what? X equal to 3. Okay, so this is a very, very good problem, right? So you need to graph all these 3 functions so you will see, what is the behavior. Okay, so now let's take a look here. Right, so be careful. Let's read these ones here. They say this function is f, oops. So this function is what? Is f double prime here. All right, so this is f double prime, and then I want to find the inflection point. Okay, so be careful. So this is f double prime. So let's do a line graph. So I have 1. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Okay, so this is f double prime. So let's put this one here. So let's put the f double prime here. Okay, so this one here is f double prime from 0 to 1. What the sign here? 0 to 1 is negative, right? Then 1 to 2 is a positive. 2 to 3 is a positive. 3 to 4 is a positive. 4 to 5 is a positive. 5 to 6 is positive. 6 to 7 is positive. 7 to 8 is what? Is a negative, right? Okay, so now let's try to graph it. So I know the F double prime is here. So this will be what? This is a concave what? Concave down here, right? Then this is all concave up, concave up, concave up, concave up, concave up, concave up. Then here, this is a concave down here, right? So where the inflection point, where is the concavity changes here? Here, right? Change from concave down to concave up. Then here's all concave up, 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 up. Then here they change again. All right. So here is they change again. So here. So now, okay. So now in here, so the inflection point is x equal to 1 and x equal to 7. So here. Okay. Now, the next thing here is, let's say, where is f prime increase and where is f prime decreasing? Remember, f double prime is the derivative of f prime here. So f prime will going to be increasing with the positive f double prime. Right? So this one will be decreasing, increasing, 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 and what? And the decreasing here, right? So where's I'm increasing? All the way from 1 to 7. And where's decreasing? From the negative infinity to 1, and from what? 7 to the positive infinities here. All right. Okay. And so those two are very, very important, because if you understand the relation, then you truly understand what is the derivatives, right? So what is the relation of f prime, f double prime, and f here? Okay, now let's take a look the last two problems here. So the problem number 4, the part 1, they said find the area of the largest trapezoid that can be inscribed in a circle of the radius 1, whose base is the diameter of the circles here. So basically, you want to find that this is a circle and the radius is 1. So basically, is you want to find this trapezoid, right? So base is on the diameter. So this is the trapezoid here, right? You want to find the area, the largest area of this trapezoid. And for this problem, we're not going to repeat here. And we did this problem, right? So you can go to the playlist optimization. You go to find the playlist optimization, and you will find the video they talk about level 3 optimization problem. Okay, so it's a third video. The optimization problem is problem number 2 here. Okay, so you can go to the channel, go find it under the playlist optimization, then you find the third video. So then the problem number 2 is exactly the same problem. You can go ahead and review that. Okay, let's take a look at the number 2 here. The number 2 here is a right circular cylinder is inscribed into a sphere of the radius is 10 centimeters here. Okay, so the radius is 10 centimeter. And then I want to find the largest possible surface area for such a cylinders here. Okay, so for this problem here, we say let's just set. So we don't need to, kind of try to take the derivative, find a critical point. That's very mechanical. As long as you can set it up, and then you'll be able to do that. Let's just get it set it up here. Okay, so now let's take a look here. So this one's here. Okay, so the cylinder. All right, so let's do a circle. Hope I can do a nice circle. All right, so this is kind of like a sphere. All right, and then I have a cylinder. Whoa, let's hope I can do that. I have a cylinder inscribed inside this sphere. I think you probably can see that. All right. Okay. So then this is the center. Okay, so here is the center of this sphere. So I can visualize, I hope you can visualize this is a sphere and is a cylinder inscribed inside of this sphere. Okay, so now let's try to see, so we just need to try to find, right? So let's take a look at what is the objective functions is. So the objective function is they want to find what? The largest possible surface area of the cylinder. So the surface area, that means I'm including the two circles and the bodies, right? Okay, so now we need to make some assumptions, right? So then we can find the values here. Okay, so now let's take a look for here. All right, so maybe I will use the color. So here, from here to here. Okay, so this is the radius for what? For the circle, so for the cylinders here, right? So this right one I say is y. Okay, and then this one here, I will say is the height to the center of this sphere. I say this is x. Okay, right? So then here, this values here for the inscribed here, this values here, I say this is the radius of this. Okay, the radius of this sphere. Okay, so I want to find the surface area. I want to maximize the surface area. So let's say the surface area. So what is the surface areas here? Surface area is a pi r square, right? The two bases here. I have two bases. So the top one and the bottom one, pi r square. Pi r square. So it's a pi y square, right? So pi y square. How many I have? I have two of them. Then plus, I'm going to find what? I'm going to find the lateral surface area, right? So it's a 2 pi r, and then what? 2 pi r, and so we need to find the circumference, and then find the height, right? So we're going to have the 2 pi r, all right, and the height. Okay, so the height here, so this from the center is the x, right? So so take a look at this is the whole height here. This is the whole height of this cylinders, right? So what is the height here? The height here is 2x here, right? Because this point is right at the center of the sphere. And so it's a half of the cylinder's height, right? So I want to do what? I want to maximize this. So this is our objective function. So if you like, you can take the 2 pi out. Then this is the y square plus 2xy here. So it's not bad, okay? Now I want to find my constraints here. Okay, so constraints here, I want to find the relation of x, y, and r. And it turns out here, the r, these r's here, the radius of the sphere, this is a fixed, right? So this is a constant. So what is the relation? Oh, that relation is pretty good. It's a Pythagorean, so it's x squared plus y squared and equal to what? X squared plus y squared is equal to r squared. Correct? Okay, and so now I can find the x or I can find the y to substitute layers, right? So it depends what you want, so it doesn't matter. So in here, I was thinking, because I only have if you see here, I only have an x here, right? So maybe I can replace the x with y. Well, doesn't matter, I guess. So you can say x squared is equal to the r squared minus y squares, right? Then the x equal to the square roots of the r squared minus y squared. Then you just substitute back to here. Then this is 2 pi. Then you have y squared plus 2. This is the r squared minus y squared times y. And then you can continue. So in here they say don't need to do that. Then you can take the derivative of SS, right, and solving it. So you can continue and solve it. As you can see, for this one here, the algebra probably become pretty tedious. So that's why for this problem, you say just set it up. You no need to continue to that. So the things here, for this problem, I think the hardest part is this objective function, right? So this objective function is hard. Then the constraints is kind of easy because after you graph it, then you know they are the Pythagorean series. So they have this very good relation, Pythagorean series. All right, that's it. That is all the problems in the chapter 4 practice test. And think we covered the majority, the key points for the chapter 4 here. All right. Okay. It's nice to talk to you, and hope that this review is very helpful to help you to prepare for the chapter 4 exams here. Okay. Bye. Talk to you later. Okay. Bye-bye.